All right, devs, welcome. We are going to be unpacking a super crucial tool for any modern backend engineer, the JSON Web Token, or as you know it, JWT. Look, if you've ever scratched your head wondering how to handle authentication in a way that's clean, scalable, and just works, well, you've come to the right place. Okay, so picture this. You're building a brand new API. Maybe it's a whole suite of microservices. And the goal, the dream, is for it to be completely stateless, right? But then you hit that classic wall. How in the world do you securely manage user logins if you're not storing any session data on your server? That's the exact puzzle we are going to solve today. So let's dive into your first JSON web token and really get into the nitty-gritty, understanding the anatomy of a token. The modern answer to that stateless login problem, more often than not, it's the JSON web token. So let's think of this as the very first tool we're going to grab out of our auth toolkit. What exactly is this thing? Come on, let's break it down. So at its heart, a JWT is really just a standard, super secure way to send information back and forth. You can think of it as a compact, totally self-contained JSON object. It's what lets a client, like a browser or a mobile app, prove who it is to a server on every single request. Okay, every single JWT you'll ever see is made of these three parts separated by periods. It looks kind of like this: a chunk of text, a dot, another chunk of text, a dot, and a final chunk. That's your header, your payload, and your signature. The header is just some metadata, like, hey, I'm a JWT, and what algorithm was used to sign me. The payload, that's the good stuff, the user data. And the signature, well, that's what keeps everything honest. Let's zoom in on these a bit more. All right, let's jump right to the middle part, the payload. Because honestly, this is the heart of the whole token. This is where all the juicy, useful information lives. It's got what we call claims, basically just pieces of data about the user. Think user ID, maybe their role, like admin. And here's the kicker. This is the info your server uses to decide what that user can and can't do, all without ever having to hit the database. Pretty cool, right? And now for the most important part, the signature. This is the trust mechanism. Seriously, think of the signature as the token's personal, very serious security guard. It's made by taking the header and payload, mushing them together, and then signing them with a secret key that only, and I mean only, your server knows. So every time a request comes in, the server does that math all over again. If the signature it calculates doesn't match the one on the token, nope, access denied. It's how we can be 100% sure that token hasn't been messed with. All right, next up, the authentication handshake. We're going to get into a step-by-step implementation flow. So we've dissected the token, we know what it's made of, but how does this all actually work in a real application? Let's walk through that whole authentication dance from start to finish. This is basically your blueprint for getting it running. Okay, so here's the flow. It all kicks off when a user tries to log in, right? They send their username and password, your server checks them, and if everything looks good, bam, it means a brand new JWT. That token gets sent right back to the client who needs to store it somewhere safe. Now here's where the magic really happens. For every single future request to a protected API endpoint, the client just tucks that token into the authorization header. It usually says something like bearer and then the token. Your server's job is now super simple. Just grab the token, check the signature, and if it's valid, the user's in. See? No session lookups in the database at all. Okay, let's talk about JWT, the essential trade-offs. It's time to evaluate the pros and cons for your project. Because look, as developers, we know the truth. There is no silver bullet. Every single tool, every architectural choice we make comes with trade-offs. So before you go all in on JWTs for everything, let's have an honest chat about the good, the bad, and the kinda ugly. First, the good stuff. The absolute biggest win for JWT is statelessness. This is a huge deal. Your server doesn't have to remember anything about who's logged in, and that makes scaling out so much easier. It's why JWTs are an absolute match made in heaven for distributed systems, like microservices. Any service can validate a token all by itself. No need to call some central session database. It's fast, it's super versatile, and it just works. But here comes the trade-off. That self-contained thing that makes JWTs great, it also creates a massive headache. You can't easily kill a token before it expires. This is the infamous logout problem. If the token gets stolen, guess what? The thief can use it until it expires. Yeah, the usual fix is to create a blacklist of bad tokens. But do you see the irony? To solve the problem, you have to add state back into your supposedly stateless system. Kind of defeats the purpose, doesn't it? So it's time for expanding your auth toolkit. because you gotta know the alternatives to JWT. If JWTs have this big revocation problem, what other options do we have? It is so important to know what else is out there because the right tool always depends on the job. Let's add a few more tools to our belt. The old school classic alternative is session-based authentication. And really, the entire difference between JWT and sessions boils down to one simple question. Where is the information stored? With JWT, all the data lives on the client, right inside that token. But with sessions, the server holds all the data, and the client just gets a simple little ID, like a coat check ticket, to prove who they are. This little comparison chart really lays it all out, doesn't it? JWT clearly wins on scalability because it's stateless. No contest. But take a look at logout control. With sessions, logging a user out is dead simple. You just delete their session from your server. Poof, they're gone. That kind of instant server-side control is a huge advantage for sessions. And our toolkit is still growing. I mean, what if you need a login with Google button? That's a whole different beast. That's where protocols like OAuth 2.0 come into play. And what if you just need two of your own servers to talk to each other securely? A simple API key might be all you need. You don't always need the complexity of user logins. The point is, there's a specific tool for just about every job. Okay, let's wrap this up by choosing the right tool. This is an actionable guide for your application. We filled up our developer toolkit with all these different authentication methods. Now for the million-dollar question, how do you pick the right one for your project? Let's boil it all down to a simple guide. Here's the rule of thumb, nice and simple. Building APIs, mobile apps, or microservices architecture? Yeah, you should probably reach for JWTs. That statelessness is just too good to pass up for scalability. But if you're working on a more traditional monolithic web app, hey, don't sleep on classic sessions. They're simple, they're secure, and that logout problem, it's just not a problem. And of course, anytime you need to let users log in with another service, you're going to be looking at something like OAuths. So there you have it. We've torn apart a JWT to see what's inside. We've walked through the entire login dance. We've weighed the pros and cons, and we've put it side by side with the other major tools in your auth toolkit. You now have a solid framework for making smart decisions about authentication. So the only question left is, now that you have the tools, what are you going to go build?